How's it going? I'm Fisher Davis, and this is my technical report presentation over piston cylinder. So first, the plan for this project is to design a piston cylinder system that demonstrates motion capabilities. The purpose of this project is, is to showcase the skills and knowledge gained through the creation of a functional mechanical model. The piston cylinder design being used is from the engine of a Chevrolet Big Block. The software being used is in SolidWorks. It's a CAD program, and the CAD program is assigned by Default Systems. So pretty much this design was made all in SolidWorks. All the blueprints are in here, which you'll see. And again, SolidWorks is a 3D modeling computer-aided system and an engineering program. First, we're going to get into the parts real quick. This is the piston crown. It's the head of the piston. It's what moves up and down throughout the cylinder. You can see I have all the dimensions out here for what was used in SolidWorks to find the dimensions. These three little rings up top, those are the oil bearings, which makes the piston slide in and out. But here it says the piston cylinder's top surface of piston inside the engine cylinder. It's a part that directly faces, seals, and compresses the combustion chamber. So next you have the rod bearing cap. This part will make sense after the next one because it connects to the connecting rod. But again, it's another blueprint. You can see each side of it. You have the vertical face. You have the bottom parts of the bearings which connect to the connecting rod. But a bearing cap assembly serves to evenly distribute the piston's load on the crankshaft and also aid in proper flow of oil. This reduces friction, prevents overheating, and increases engine. And now we have the connecting rod shaft. So what I was saying earlier, the bearing cap connects to this half circle in the end. You can see all the different angles in the 3D view, which is fully projected after the blueprint was finished in SolidWorks. But pretty much a connecting rod, also called a con rod, is part of the piston engine, which connects the piston to the crankshaft. Together with the crank, the connecting rod converts the reciprocating motion of the piston into the rotation of the crankshaft, which I think is next. Get to this next slide. Okay, now here is the gudgeon pin or G pin, but the gudgeon pin is named for the pin that connects the piston to the connecting rod in an internal combustion engine. So this little rod goes inside the bearing cap, not the bearing cap, it goes inside the piston crown. You can see on the first slide there's a hole in the crown, and it goes through there, and that's what connects. This part rotates within the connection rod, and that's what moves it up and down, and that's what connects everything together. And now we have the crankshaft. So this is what makes everything move. You can see on the end, that's the motor, and then on the inside, that's where the piston cylinder would be. The head would be at the top on these two little triangle pieces, and then on the right you can see that's what would connect to the engine. But the crankshaft is a crucial component in the piston cylinder assembly, converting vertical reciprocating motion to the pistons into rotational motion. This rotational motion is what powers the engine and ultimately drives the vehicle of machinery connected to the piston via connecting rods. The crankshaft rotates as the piston moves up and down, transferring force throughout the engines. So this is a motion analysis. Rotary motion provides the crankshaft for realistic movement. Piston achieve full stroke without contact or interference. Connecting rod maintained smooth pivoting motion. Initial misalignment fixed with improvement cylinder piston mates, and final simulation confirmed correct rotational to linear motion. So I did have a video of this on the slide, but it wasn't working, and pretty much all these points are just talking about how all the parts that were saw previously, they were all put together and made the piston cylinder, which moved up and down. And there was some trouble with keeping it linear and keeping the piston crown in one spot, because it would fall off and it would come apart. But eventually we were able to get a final simulation and confirm the correct motion. So here we have the motion, which we just talked about, and then the mates. So the mates was crucial to, or is crucial to an assembly in SolidWorks, because that's how you assemble the cylinder together. But there's concentric mates. They're used to align the piston pin, rod, and crankshaft. So that's just making each circle fit with a circle. It's concentric sounds complicated, but it's really not. Connecting rod, big end mated to the crankshaft for rotation. I'm on mates right now, and width mate centers the rod between the crank webs. That was difficult. That's the space in between where the engine rotates. That's where the connecting rod and the bearing cap meet, making that circle, and that's what goes around the web in between the crankshaft, which makes it go up and down. The cylinder walls, this was very difficult. The cylinder was the piece that goes over the top of the crown. It was really hard to keep that inside of the piston crown, or the piston crown inside the cylinder, because it would stay, like, you had to make it concentric to the walls of the cylinder, and it would move up and down, and sometimes it would treat it as one piece and it would move everything at once, or the piston cylinder would move in and out of it and the bottom would move instead of just rotating. But motion was previously explained, and that's some of the troubles we had with the mates, and some of the successes that we had with the mates. So finally we have the discussion. The piston cylinder moved smoothly, and motion analysis in the project was overall success. Some design details could have been improved for sure, but the time constraints limited refinement. Most mates were used, were concentric or collinear, and determining correct dimensions required several adjustments. Early motion attempts failed because parts separated, like saying when they fall apart during the assembly, but added a guiding line under the piston. There's a line that you can make on SolidWorks, so whenever you have an object in SolidWorks, you can keep it in one spot by mating it with a line or with another part. So that was helpful for fixing the piston head problem. And creating the motion, the video, which was not on here, required selecting the correct motor placement and tuning settings. And finally, the recorded motion, it ran smoothly with 50 rotations per minute with a frame of 50 frames per second for a clean animation.